All right, let's jump right into it. 7.1 through 7.2, greatest common factors for polynomial terms. So let's just review what factors are and then greatest common factors, and we'll see how they apply to polynomials. So let's figure out the factors of 420, and the way that we want to do that is by finding the prime factorization, and the way we want to do that is by making a factor tree. So recall, we make two branches. What two numbers multiply together to get 420? 10 and 42. We can break down 10 into 2 and 5. These are done, so we can circle them. 42 is the same as 3 times 14, yeah. 3 is a prime, so we can circle it, and then 14 is the same as 2 times 7. So the prime factorization of 420 is 2 times 2 times 3 times 5 times 7. And if we want to just simplify that, that's 2 to the power of 2 times 3 times 5 times 7. That's the prime factorization of 420. Now, if we want to do 48xy squared, we can do the same thing. But the first step we want to take is breaking it into the coefficient and the variables. Okay. We can break up 48 into 4 times 12. There's a little bit of a lag in my board and pin, so that's confusing me a little bit. 4 is broken down into 2 times 2. We can circle that. 12 is the same as 2 times 6, and then 6 is the same as 2 times 3. Okay, and then x and y squared can be broken down into x and y squared. X is as low as it can go, and then y can be broken down into y times y. All right, so once we wrap it all up, the factorization would be 2 to the power of 4 times 3 times x times y squared. Okay, and if we wanted to find the greatest common factor between the two, we just find well, let me go back a step. I skipped a step over here. This is the same as 2 times 2 times 2 times 2 times 3 times x times y. Don't skip that step. I shouldn't have. So if we want to find the greatest common factor between these two, we find what they each have in common. They got a 2 in common. They got another 2 in common. They got a 3 in common. And so the greatest common factor of these two would be 12. Okay. Anyway, factor trees. We're going to be using them a lot. So let's see how this applies to a polynomial. So at the bottom of 229, we'll use the example of, ignore that, that's from a previous lesson. We'll use the example of 10x4 plus 5x3 plus 20x squared. So it wants us to find the greatest common factor of these three terms. Okay, so what we can do, let's just make a tree for each of these. So that's 10x to the power of 4, 5x to the power of 3, and 20x to the power of 2. So we want to break it down into coefficients and variables first. Okay, that's going to give us 2 and 5. This is going to give us 4 x's, x. Okay, so 2, 5, and the 4 x's. 2 times 5 times x times x times x times x. This is going to give us 5x3, which is just going to be 5 and then x. 5 times x times x times x, and then this is going to give us 20x squared, which is going to be 4 times 5, which is 2 times 2, prime, x, which is going to give us 2 times 5 times x times x. So if we want to find the greatest common factor, let's circle everything they have in common between all three. So is there 2 in all of them? No, there's not a 2 in this one, so 2's out. Is there a 5 in all of them? Yes, there is. Okay. And is there an x in all of them? Yes, there is. And is there another x? Yes, there is. So the greatest common factor between these three things is 5x squared. Okay, so what we can do with this information is we can do our reverse distribution. So instead, distribution is you know, it's when we have a number x plus y and we multiply 2 into each thing, and that gives us 2x plus 2y. Reverse distribution is finding everything they have in common and pulling that common thing out and putting it to the outside the parentheses. So they each have a 2 in common, so we can pull out the 2 in front and get 2 times x plus y. So this is essentially what we're doing here. So we're going to reverse our distribution. So now, how do we know what we have left in the middle? Well, it's just whatever's left over of the greatest common factor. So we've already used this 5x and x, so what's left over for this first term is 2x squared. What's left over for this middle term is just an x, and what's left over for this last term is a 4. Okay, so what this does for us is it just takes out everything in common, and we can see the greatest common factor out front. And if you notice, if we were to just distribute everything back in, 5x squared times 2x squared gives us 10x4. 5x squared times x is 5x3, and then 4 times 5x squared is 20x squared. So we can see that we get exactly what we started with. So what we're doing, it's just called factoring, and it's just pulling out the greatest common factor and writing it in this form right here. This is what we wanted to accomplish. We wanted to pull out the greatest common factor and simplify in the middle. Okay, we want to do a similar thing here. We have a polynomial, but we want to take out the greatest common factor, put it outside of a distribution, and see what we got. So what we want to do is just make some trees. All right, so we've got 8 times x7, we've got 4 times x6, and we've got negative 12, okay? Because this is associated with this. We don't want to forget our negatives. Super important. x3. All right. Let's divvy everything out. X is going to be 2 times 2 times 2. And then we got 7 x's. All right. 4 is going to be 2 times 2. And then we got 6 x's. And then let's take special care right here. This is going to be negative 1 times 12, and then 12 breaks into 4 and 3, and then 4 is 2 times 2. So here we've got negative 1, 2, 2, 3. Now, even though negative 1 is not a prime number, we do need to write it in our factorization. Super important. And then x is just going to be x times x times x. All right, so what we're left with is negative 1. Once again, there's a lag. 2 times 2 times 3, sheesh, times x times x times x. All right, so let's find everything they have in common. So, oh, I used blue last time. All right, so do they all have a 2 in common? Yes, they do. They have 2 2's in common. 2 2's. They don't have a 3 in common. How many x's do they have in common? Looks like they have 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right. So what's our greatest common factor? 2 times 2 is 4, and then x times x times x is x to the power of 3. So what we're left with on the inside is going to be what's left over. 2 times x times x times x times x, that's 2 times x to the power of 4. Over here, we're just left with x to the power of 3. And over here, we have negative 1 times 3, so that's a minus 3. That's why we need to take care of our negative signs, because we can't lose it. All right, so this is how we simplify things by factoring, and if we just want to check it, we can multiply through. 4x cubed times 2x4 is going to be 8x7. 4x cubed times x cubed is going to be 4x6, and then negative 3 times 4x cubed is negative 12x cubed, which is what we started with. So we know what we got here is correcto. And then we'll do one more. We'll actually do 2 more. So we're going to example 7.2c on the bottom of 230. Okay, so we have this polynomial here. Now, this polynomial is a little different than things we were looking at previously, because looks like we have a distribution going on. but we don't want to distribute through. We just want to treat these as two separate terms, okay? Just like these are individual terms right here, that's a term, that's a term, and that's a term. What does it mean to be a term? It means it's separated by a plus or a minus. So that's how we know where our term divisions are. We want to look at this and recognize where are our terms. Well, our plus and our minus, there's only one, and it goes right here. Okay, so we have two terms. Now, these are also pluses and minuses, but these are in parentheses, which means they've been separated from they're in their own little box. So we're not making a division based on that. So we want to still do a factor tree. Now remember, what does it mean to be a factor? A factor? It means it's just two things that are being multiplied together. So looking right here, where's the multiplication at? It's right here. So that means one of our multiplications is x, or one of our factors is x, and the other is a minus b. Just like back here, 8 times x to the 7, the multiplication is happening right here, which is where we make the division, or where we make the split. So just like over here, that's where we make the split. Neither of these things can be simplified any further, so we have x times a minus b. Then over here, where's the multiplication happening? It's right here. So we make the split, -6, then a minus b. Okay, this can split into -1 and 6, and then that becomes 2 and 3. So over here we're left with -1 times 2 times 3 times a minus b. So what do they have in common? They have this a minus b in common. Okay, so we can write that on the outside of the distribution, a minus b, and then what we're left with in the parentheses over here, what's left over from this term? Just an x. All right, and what's left over on this term, -1 times 2 times 3, is -6. So looky here. So we turned this phrase, kind of repetitive and long, into just two binomials being multiplied together. So this is why we like to do this factoring, because it can simplify the problem up for us. Because now, instead of having to deal with a minus b twice, we brought it out to the front. We only have to deal with it once in our problem, and this is a lot nicer than writing this whole thing out. And before we get to the last one, I need to show you one little extra thing. So let's say we have x plus 3 over here, and let's say we have maybe that's not what I want. No, let's say we have x minus 3 right here, and let's say over here we have 3 minus x, okay? Now, these two things, they look kind of similar because they both have the same, they're not the same terms, because this is a positive x, this is a -3, this is a negative x, this is a positive 3. But they have the same value pretty much, right? They just have different signs. So what would happen if we multiplied this by -1? What would we get? Well, if we distribute, -1 times x is -x, and -1 times -3 is +3, all right? So still a little different from what we have over here, but using the commutative property, we know we can just move these things around, which gives us 3 minus x, okay? So see, we started with x minus 3, and we came up with 3 minus x. Now, the point of this is to show you that these two things are related through a multiplication of -1. So they are multiples of one another, okay? So if you come across this, you know that it's the same as this times -1, and if you come across this, it's the same as this times -1, okay? The reason I taught you that is because it's showing up in our next one. All right, so it wants us to factor, so we'll do what we're doing. So let's figure out what our terms are. We got one term here, and we got the other term here. Okay, so let's make our trees. So right here, what's being multiplied? Well, let's first split off the parentheses. So we got 3x times x minus 5. And then from the over here, we can split up the coefficient of the variable, 3 and 3x. So we're left with 3 times x minus 5. And over here, we've got 2 times 5 minus x. And if we stop there, we wouldn't have anything in common. No 3, no x minus 5, and then 5 minus x. But what we just learned is that this is the same as -1 times x minus 5. Okay, so here are our three terms. So we've got -1 times 2 times x minus 5. So now with us knowing that little trick, what are the things in common? We got an x minus 5 and an x minus 5. So we'll bring that to the front. All right, and then what's left over will be our remaining polynomial. 3 times x is 3x, -1 times 2 is -2. And once again, we've turned this long thing into a simplified 2 polynomial phrase. All right, write down any questions you have, and I'll put your homework in the Excel sheet.